The Spitfire is not just an aircraft. It is a national icon, a marvel of engineering, and a decisive force in wartime history. Over a decade, it dominated the skies, proving to be one of the most formidable weapons ever created. Today, its legacy lives on, symbolizing courage and victory. At one of Britain's most famous wartime airfields, a team is breathing new life into these legendary planes. Amidst heaps of wreckage, proud owners and engineers work tirelessly to restore Spitfires to flying condition. Over 9 months, cameras follow a dedicated team as they rebuild these historic aircraft, using original tools, methods, and blueprints from the 1940s, scouring the world for authentic components. The restoration is challenging. Parts are rare, budgets are tight, and deadlines loom. The engineers must carefully reconstruct every element to ensure the planes can fly safely. Each day is filled with the sounds of banging, clattering, and relentless problem-solving. At the heart of these restorations is a quest to honor the aircraft's history while keeping them operational. Every bolt, rivet, and tube is inspected, crafted, and fitted with precision. A single mistake could compromise the plane's performance or safety. Despite the intense workload, the team is driven by passion and respect for the Spitfire's legacy. Peter Monk, a seasoned restorer with multiple projects underway, oversees the Greek Spitfire's restoration. Known for his expertise, Peter balances 5 major restorations, prioritizing one critical project to be ready for flight within 10 weeks. The aircraft, a Mark 9 Spitfire with clipped wings, ideal for altitude operations, has been freshly painted in Greek Air Force colors. The assembly is in its final stages, with most components completed, and the team focuses on finishing the intricate sub-assemblies. Cooperation is essential. The more hands involved, the faster progress is made. Today, the focus is on the engine bearer, a crucial part of the fuselage frame, engineered by specialist Mark Britnell. He meticulously assembles the frame, drilling holes, aligning tubes, and ensuring every piece fits perfectly. The engine bearer, designed to withstand extreme forces, is critical in linking the engine to the fuselage. Tubular rivets, custom-shaped steel fasteners, and precision engineering allow it to endure the enormous torque generated by the spinning propeller. As the engine flexes in flight, the bearer absorbs shock and maintains structural integrity. Frame 5, where the engine bearer attaches, must endure the combined weight of a 3/4-ton engine and the stresses of high-speed maneuvers. Remarkably, the engine is held in place by just 8 bolts, testament to the Spitfire's extraordinary design. R.J. Mitchell and his team designed the Spitfire in the 1930s without computers or modern simulators, yet they created a craft that could handle the rigors of air combat. The Greek Spitfire's engine, a Merlin 66, is restored with painstaking attention to detail. Introduced in late 1941, the Merlin 66 offered enhanced low-altitude performance in over 1,700 horsepower, thanks to a 2-stage supercharger. The restoration team tests every component, repairs or replaces worn parts, and ensures the engine's readiness. Some pipes and fittings are manufactured from scratch, requiring careful shaping and soldering, reflecting the dedication of each team member. Testing the Merlin engine is a high-stakes process. The team mounts it on a mobile test rig, simulating the stresses of flight while monitoring critical parameters such as RPM, temperature, and fuel flow.
Safety is paramount, as the engine's 1,700 horsepower can literally lift the truck it sits on if not properly restrained.
Over 500 hours of projected use, each component is scrutinized, reflecting the exacting standards of wartime production. The test confirms the engine operates safely, marking a major milestone in the Greek Spitfire's restoration. Parallel to these technical achievements, the program celebrates historical milestones. One vital contribution to the Spitfire's wartime success came from Beatrice Tilly Schilling, an engineer who solved a critical problem with the Merlin engine's carburetor. Early versions would stall under negative G maneuvers, a tactic German pilots used to escape combat. Schilling's elegant solution, a simple washer restricting fuel flow, allowed British pilots to outmaneuver enemy aircraft without engine failure. Her innovation, implemented across air stations, saved countless lives and cemented her place as a pioneering figure in aviation history. The Spitfire's versatility extended beyond conventional fighter roles. It was adapted for reconnaissance missions, with cameras and extra fuel tanks installed to replace armaments. Pilots operating at altitudes of 30,000 to 40,000 feet endured bitter cold and long hours alone, relying on skill and courage to complete critical intelligence missions. Photographers and interpreters on the ground meticulously analyzed thousands of images, mapping enemy positions, ammunition depots, and strategic targets. This information proved crucial for planning operations such as D-Day, demonstrating the Spitfire's pivotal role in gathering intelligence and shaping strategy. Keith Quilter, a veteran naval pilot, exemplifies the dangers and challenges faced by those flying Spitfires in specialized roles. Serving in both the Atlantic and Pacific theaters, Quilter flew Seafire aircraft, naval variants adapted for carrier operations. Landing on carriers was perilous due to poor cockpit visibility and the need to catch arrestor wires precisely. Pilots risked accidents or fatal crashes if miscalculations occurred. Quilter survived numerous hazardous landings, kamikaze attacks, and high-stress missions, showcasing the courage and resilience of Spitfire pilots. Throughout the war, Spitfires continued to evolve. The Seafire featured hydraulically folding wings, contra-rotating propellers, and speeds exceeding 450 miles per hour. Even post-war, it remained in service alongside emerging jet fighters during the Korean War, a testament to its enduring design. Reconnaissance pilots like Quilter operated at extreme altitudes and for long durations, demonstrating the aircraft's adaptability and the human endurance required to extract vital intelligence. Every photograph captured informed strategic decisions, ultimately shaping the outcome of military operations. Meanwhile, the restoration team remains focused on their mission. At Big Hill, installation of the Greek Spitfire's Merlin engine progresses, with dozens of components fuel, cooling, hydraulic, pneumatic, meticulous systems being meticulously connected. Original parts, including rudder pedals and control handles, preserve the aircraft's authenticity. With 7 weeks until the deadline, the team mobilizes all available personnel to complete the complex assembly. After nearly 2 years, the Spitfire is closer than ever to taking flight once again, a living tribute to engineering brilliance, historical legacy, and the determination of those who restore it. After the engine is installed at Big Hill, the next step is connecting all remaining systems: fuel lines, cooling circuits, hydraulics, pneumatics, and electrics. Each component must be fitted with precision, as even a small error could compromise safety or performance. The Merlin engine, weighing over 3/4 of a ton, is secured with concrete blocks to prevent any movement during installation. Dozens of bolts, wires, and pipes are carefully routed and locked in place, adhering to aviation standards established during the 1940s. This painstaking work ensures the restored Spitfire maintains both authenticity and functionality. Every element of the cockpit reflects the aircraft's history. Original rudder pedals, control columns, throttle handles, and undercarriage selectors bear the wear of pilots who flew these planes during the 1940s. Each scratch, dent, or worn surface tells a story of wartime missions, dogfights, and high-altitude reconnaissance flights. The restoration team photographs progress for the owners, documenting every stage of assembly and providing a permanent record of the work undertaken. With just 7 weeks remaining, the team works around the clock, maximizing efficiency and ensuring nothing is overlooked. While the restoration continues, attention turns to the Spitfire's historical significance. Pilot Jez Britcher explores its role in reconnaissance missions, a lesser-known but crucial function during World War II. Australian engineer and inventor Sidney Cotton pioneered photographic reconnaissance for the RAF, proposing the use of Spitfires for long-distance intelligence gathering. Initially, the RAF hesitated, as fighter production was limited and the Spitfire's capabilities and unarmed reconnaissance were untested. Ultimately, 2 Spitfires were converted for the role, stripped of weapons, painted blue, fitted with cameras and extra fuel tanks for missions at altitudes exceeding 30,000 feet. Reconnaissance pilots faced extreme challenges. They endured bitter cold, oxygen deprivation, and long solitary flights over enemy territory. Their only defense was altitude, speed, and the ability to evade enemy fighters. The photographs they captured were meticulously analyzed by over 1,000 interpreters, trained to identify military installations, ship movements, and strategic targets. Accurate intelligence proved critical for operations like D-Day, as landing craft commanders relied on maps and aerial images to guide troops safely ashore. The reconnaissance effort was labor-intensive, precise, and indispensable to Allied success. Keith Quilter, a 97-year-old veteran, recalls his experiences flying Seafire aircraft, naval variants of the Spitfire, adapted for aircraft carrier operations. Early models were challenging to land due to limited cockpit visibility and the difficulty of catching arrestor wires. Pilots often faced near-fatal landings, with aircraft sometimes hanging over the side of the carrier or crashing despite their skill. Quilter survived multiple kamikaze attacks while serving in the Pacific Theater, demonstrating the extraordinary courage required of Spitfire pilots. Even when shot down, he managed to avoid capture and survive until the end of the war. A rare and remarkable feat. The Seafire continued to evolve, incorporating hydraulically powered folding wings, contra-rotating propellers, and speeds exceeding 450 miles per hour, the Mark 47. The most advanced Spitfire variant remained operational alongside early jet fighters during the Korean War. These adaptations highlight the Spitfire's versatility and enduring relevance, capable of performing diverse roles from air superiority to reconnaissance. The aircraft's aerodynamic perfection, however, sometimes complicated carrier operations requiring precise skill and innovation from pilots. The restoration team's dedication mirrors the ingenuity of wartime engineers. Installing the engine involves hundreds of small but critical components, each connected with exacting precision. Fuel lines, coolant systems, and hydraulic pipes are carefully aligned, ensuring smooth operation once the aircraft returns to flight. Magnetos supply electrical energy to spark plugs, radiators maintain engine temperatures, and compressors control brakes and flaps. Nearly all parts are original, preserving authenticity and honoring the history embedded in every rivet, bolt, and tube. Simultaneously, the story of Beatrice Tilly Schilling illustrates the human innovation behind the Spitfire's success. Early Merlin engines would stall under negative G maneuvers, a vulnerability exploited by enemy pilots. Schilling's simple yet ingenious solution: washer restricting fuel flow loud. British pilots to execute complex aerial tactics without engine failure. Her work, often carried out with a team of women engineers, was implemented across RAF air stations, saving lives and enabling Allied pilots to maintain aerial superiority. Nicknamed Mrs. Schilling's orifice, her invention exemplifies how elegant, straightforward engineering can have profound wartime impact. The Greek Spitfire's restoration culminates in engine installation, with Peter Monk supervising every stage. The Merlin engine is carefully lifted and bolted into place, ensuring perfect alignment with the fuselage. 8 bolts secure the engine, while dozens of connected systems guarantee operational integrity. Each step requires coordination and precision, as the team navigates a complex web of wires, pipes, and mechanical components. The process honors the aircraft's original design, reflecting the meticulous craftsmanship of engineers from over 80 years ago. Once installed, the engine undergoes testing on a mobile rig. This simulation replicates flight conditions, measuring RPM, boost pressure, and mechanical responses under load. The Merlin engine generates immense power, requiring careful stabilization to prevent accidents. During tests, engineers monitor every parameter, verifying that the engine operates safely and efficiently. Successful testing ensures the restored Spitfire is airworthy, combining historical accuracy with modern safety standards. The achievement reflects thousands of hours of labor, dedication, and expert knowledge. Beyond technical achievements, the Spitfire's role in World War II highlights the courage of those who flew and maintained it. Reconnaissance missions over Norway involved photographing enemy battleships like the Tirpitz, which threatened Allied convoys. Pilots operated alone at extreme altitudes, enduring freezing conditions and relying on precise navigation. Photo interpreters on the ground identified targets and analyzed intelligence, providing critical data for strategic operations. These efforts directly contributed to the success of attacks and the eventual neutralization of key enemy assets. Keith Quilter's experiences in the Pacific Theater further underscore the hazards faced by Spitfire pilots. Kamikaze attacks threatened aircraft carriers, and pilots had to be ready to launch at a moment's notice. Quilter's skill, endurance, and composure ensured he survived multiple attacks, including being shot down and rescued by a submarine. Witnessing the aftermath of the second atomic bomb on Nagasaki, he reflected on the fragility of life and the extraordinary circumstances of wartime aviation. His story, alongside those of reconnaissance pilots and engineers, encapsulates the bravery and resilience inherent to the Spitfire's history. Back at Big Hill, as engine installation concludes, attention shifts to the aircraft's final assembly. Propellers, fuel lines, electrical systems, and hydraulic connections are meticulously fitted. Each step is documented, creating a detailed record for future reference. The team works systematically, ensuring that every component functions correctly and matches historical specifications. After nearly 2 years, the Greek Spitfire is close to completion, ready to take to the skies once more. The project stands as a testament to engineering excellence, historical preservation, and the unwavering dedication of those restoring this iconic aircraft. The restored Spitfire not only represents technical achievement, but also serves as a living tribute to the men and women who contributed to its legacy. Pilots, engineers, interpreters, and innovators like Tilly Schilling played crucial roles, combining courage, skill, and ingenuity. Every flight, every component, and every historical anecdote reminds us of the human effort behind the machine. The restoration process, though painstaking and complex, ensures that this legacy endures. It's inspiring future generations to appreciate both the engineering brilliance and the human stories behind the Spitfire. As the Greek Spitfire nears completion, the excitement and pride among the restoration team are palpable. Each member has contributed expertise, time, and passion to recreate a piece of history. From engine testing to cockpit assembly, every step preserves authenticity while ensuring safety and performance. The aircraft is poised to return to the skies, ready to honor the legacy of those who flew the Spitfire in war and peacetime. Through meticulous craftsmanship and dedication, the team has resurrected an icon. Blending historical fidelity with the thrill of flight, the Spitfire's journey, from its wartime origins to modern restoration, exemplifies resilience, innovation, and dedication. Its legacy spans decades, encompassing technical brilliance, tactical ingenuity, and human courage. From pilots like Keith Quilter to engineers like Peter Monk and Tilly Schilling, countless individuals contributed to its enduring story. The restored aircraft stands as a testament to these efforts, a tangible reminder of a remarkable era in aviation history. Every bolt, rivet, and engine component embodies the skill and determination required to keep this icon flying. Finally, the restored Spitfire is ready for its first test flights, representing the culmination of years of effort and devotion. Engineers and pilots alike celebrate the achievement, recognizing the historical significance and technical mastery involved. As the aircraft takes to the skies, it embodies not only the engineering genius of R.J. Mitchell and his team, but also the bravery of the men and women who ensured its success during the war. The Greek Spitfire is more than a machine. It is a living symbol of innovation, courage, and the enduring legacy of the Spitfire.